Insignificant.
I can't think of a better single word to describe what learning about the universe makes us feel like. Carl Sagan said it best when he stated,
"Astronomy is a humbling and character-building experience."
And that, in the vast scale of the universe,
we have good reason for humility.
However, that's certainly not the only thing most people feel. The senses of awe and amazement at the sights and environments existing in space that we have been able to observe with increasing focus as technology advances are also common feelings. In other words,
space is so cool! I love space so much!
Though, before we begin, it would probably be best to clarify what the video title really means. It could more accurately read, the 15 supposedly largest features, objects, structures, and things in the universe, arbitrarily organized by type, that humans currently know of as of August 2017. Doesn't really roll off the tongue though. But without further delay, let's get existential.
Number 15.
The largest crater, Utopia Basin. Mars has had a pretty tough time since its formation. Technically, Mars falls just within the habitable zone, making it close enough to the Sun to support liquid water. But 500 million years after its formation 4.6 billion years ago, it somehow lost its internal dynamo, destroying its magnetic field, which meant no more atmosphere or liquid water. There are two theories as to why this is. The first being that Mars is too small to support a magnetic field for long, and the second is that Mars lost quite a bit of material and had its convection greatly disrupted by some truly massive impacts. Utopia Basin was most likely formed by one such collision. Using Kansas for comparison, let's look at the size of Chicxulub crater caused by a 10-kilometer meteorite and thought to be the final nail in the coffin for the dinosaurs. Next, we'll look at the Vredefort crater, the largest confirmed crater on Earth at 300 kilometers in diameter with a 12 to 15 kilometer impactor. Now, let's compare these to Utopia Basin.
Oh my goodness!
Yeah, it's that big. That's 3,200 kilometers in diameter, the distance from Las Vegas to Washington, D.C. That's almost the diameter of our moon. The object that struck Mars would have been over 100 kilometers across and must have caused a colossal impact, changing the geography of half of the planet, perhaps killing off all chances Mars had for housing life nearly 4 billion years ago.
Number 14.
The largest asteroid, 1 Ceres. All that talk about potentially apocalyptic meteorite strikes earlier does inspire another question. What's the largest asteroid that we know of? Hundreds of thousands of them have been discovered thus far, but there may be billions of them larger than 50 meters in size in our own solar system. The largest asteroid was also the very first discovered in 1801 by Giuseppe Piazzi, which he named Ceres. Yes, he named the 945 kilometer in diameter lifeless ball of rock and ice after the Roman goddess of agriculture. NASA's space probe Dawn entered Ceres' orbit on March 6, 2015, and has been taking high-resolution photos of the surface of Ceres since then. The two features that stick out most on the cratered surface of Ceres are very reflective bright spots and a lone mountain on its surface. Scientists theorize that the bright spots are simply ice or salt, but the mountain was something exciting. Ahuna Mons was the name given to the mountain, and it is one of the tallest in the solar system at 4 kilometers high. Scientists believe the mountain was formed by volcanic activity, not with magma mind you, but instead, water. That means Ahuna Mons was formed by a cryovolcano, or cold volcano, that erupts water and methane instead of melted silicate rock. That, coupled with the fact that Ceres may contain more water than all of the fresh water on Earth, makes it a seriously cool asteroid. Haha, I wouldn't have laughed at that either.
Number 13.
The largest moon, Ganymede. Jupiter is
Humongous.
It's so big that 1,300 Earths could fit inside of it, with room to spare. So it's no surprise that it also has the gravity to hold on to a whopping 67 moons, 3 of which are actually larger than our own moon. Ganymede is the largest of Jupiter's moons and the largest in the solar system at 5,268 kilometers in diameter. It even dwarfs Mercury. But that's not the only thing special about Ganymede. It's also the only moon in the solar system to have a magnetic field of its own, most likely due to a liquid iron core. Around 40% of Ganymede's composition is ice, and the other 60% are rocky material, which is easily seen on its surface as the darker cratered areas. But 100 kilometers underneath the surface of rock and ice is another wonder. Possible oceans of water kept liquid by high salt content and perhaps the heat from Ganymede's core. Europa, another of Jupiter's moons, also houses liquid water beneath its surface, though it is far more likely to possibly house life compared to Ganymede.
Number 12.
The largest planet, ROX-42b, b. Objects several times more massive than Jupiter that are unable to fuse hydrogen in their cores are commonly referred to as brown dwarfs, but the line between what counts as a planet and a brown dwarf is fuzzy. For the sake of not taking 10 minutes on this subject alone, I'll just go with part of the International Astronomical Union stance and say that a planet is any planet-sized object that doesn't fuse anything at all. So, since planetary bodies 13 times the mass of Jupiter can fuse deuterium, I'll define the largest planet as something just under that. Discovered in 2013, ROX-42b, b has a radius 2.5 times the size of Jupiter's at around 175,000 kilometers and a mass of 6 to 12 times that of Jupiter's. Please note that measuring the physical characteristics of faraway planets is difficult and subject to change as imaging techniques evolve, so here are a few of the closest competitors for the largest known planet. Focusing once again on the current largest planet, ROX-42b is around 140 astronomical units from its host binary star. That's 30 times further than Jupiter is from our Sun, and 3 times the distance of Pluto to our Sun. ROX-42b's enormity and distance from its host star is an odd circumstance that has many astronomers wondering how it formed, especially considering how young the solar system is. The solar system is just 1 to 3 million years old and relatively close at 400 light-years away in the breathtaking Rho-Ophiuchi cloud complex, so perhaps further study may bring us closer to understanding how oddball planets and brown dwarfs form.
Number 11.
The largest star, Scuti. There are a couple of provisos that come with naming the largest star in the universe. First, measuring the exact size of a star when it's hundreds to millions of light years away is difficult, especially when the luminosity can vary over time. Because of this, there's a margin of error that can place large stars over 100 solar radii smaller or larger than its estimate. Currently, Scuti is believed to be the largest star at 1,708 plus or minus 192 solar radii at a distance of 9,500 light years from Earth. Using that estimate, Scuti is nearly 5 billion times the volume of the Sun. It's hard to appreciate just how monumental that is, so let's do a quick size comparison. Here's the Earth in comparison to our Sun. It would take about 109 Earths to fit the size of the Sun's diameter, and 1.3 million Earths to fill up the Sun's total volume. Now, here are the Earth and Sun compared to Scuti. Unfortunately, we lack the budget to illustrate it, but nearly 6.5 quadrillion Earths would be needed to fill up Scuti's average volume. That's 6.5 million billion Earths. Because this is most likely impossible to imagine, try imagining if our Sun was scaled down to the size of a tennis ball. To scale, Scuti would be slightly larger than the Ericsson Globe, a 28-story tall hemispherical building with a diameter of 110 meters capable of holding nearly 14,000 spectators for hockey matches. And Earth would be a grain of sand just over half a millimeter in diameter. Scuti's colossal size is fleeting though, as it is expected to fuse its supply of lighter elements in the next million years before going supernova and forming a stellar black hole or neutron star.
Number 10.
The largest black hole, S50014 plus 81. The same provisos mentioned for the largest star apply here as well, but even more so as the largest possible black holes known range from millions to billions of light years away from us. The event horizon of a black hole is the point at which nothing, not even light, can escape its gravity. An accretion disk is the material, including dust, planets, and even stars orbiting the black hole outside of its event horizon. The phenomenal brightness coming from an accretion disk surrounding a supermassive black hole is what we call a quasar. But the luminosity of S50014+81 is in a special class of super bright quasars known as blazars. S50014+81's accretion disk is one of the brightest in the universe and is 25,000 times brighter than every one of the hundreds of billions of stars in our own galaxy combined. Its event horizon, the sphere of matter that doesn't allow even light to escape, is monstrously huge at 237 billion kilometers in diameter. That would engulf our entire solar system up to Pluto's orbit 37 times over. And its mass? Perhaps 40 billion times the mass of our Sun, though exact measurement is difficult. For comparison's sake, a regular stellar mass black hole is just 3 to 4 times the mass of our Sun.
Number 9.
The largest nebula, NGC 604. Nebula is a sort of nebulous term, if you'll forgive the horrible pun. So to narrow things down, H2 regions will be what are specifically compared, as they make up some of the most spectacular sights in our skies and are crucial for star development too. NGC 604 is the largest H2 region known and is a mammoth star-creating engine 1,500 light-years across, located in the Triangulum Galaxy. It's so bright and enormous that it would outshine Venus in our sky if as close as the famous Orion Nebula. There are no doubt larger H2 regions elsewhere in the universe, but due to their faint nature, we have yet to have discovered them, as they are simply clouds of dust strung out over light years of space. Nebulae get their brightness from stars forming within the dust, giving off incredible hues of color. Though once H2 regions begin producing stars, their days are numbered. The very stars H2 regions produce ionize the dust with intense light rays over time, and once a supergiant star born within the dust goes supernova, it will blow away most of the dust after thousands of years. Because of this, H2 regions only last for a few million years at a time, so enjoy viewing these stunning star nurseries while you can.
Number 8.
The largest galaxy, IC 1101. When determining the largest galaxy in the universe, it's important to mention that the largest galaxies known are usually millions to billions of light years away, which makes accurately determining their size difficult due to the way light diffuses through space from that distance. Our own Milky Way galaxy has a diameter of 100,000 light years, give or take a few thousand light years, and is populated by 100 to 400 billion stars. That's so huge it's already difficult to visualize, but our galaxy is only mid-sized. The universe is vast, and within it are some truly gargantuan galaxies. IC 1101, a brilliant yellow supergiant elliptical to lenticular galaxy, is the largest that we currently know of, with a diameter of perhaps 4 million light years, give or take a few 100,000 light years. At that size, IC 1101 could contain 10 to 100 trillion stars, each with their own solar systems and possible planets, all at a distance of over 1 billion light years from us. What determines the boundaries of a galaxy is also uncertain for now, so although IC 1101 has the largest halo of diffuse light, it is debated whether or not we should accept the gas surrounding the galaxy reflecting light as part of the galaxy. Though even with that caveat, IC 1101 is the largest galaxy currently known to us, and even larger ones may yet to have been discovered.
Number 7.
The largest blob, Newfound Blob. Lyman alpha blobs are special giant structures of gas emitting light along the Lyman alpha line, meaning that, with a special filter, large blobs of gas can be seen in space. Lyman alpha blobs are a very recent astronomical discovery, but their size and density are exciting. Though only a few dozen blobs are known, most are hundreds of thousands of light years in size, and even though many are larger than our own galaxy, they are incredibly dense in comparison to nebulae. That density is important because it could mean that Lyman alpha blobs are precursors to galaxies, which makes the largest known blob even more incredible. Discovered in 2005 by a Tohoku University research group, Newfound Blob, which is just a placeholder name so you don't have to refer to it as this long string of characters, has a length of 200 million light years. But that's not all. It's measured to be over 12 billion light years away from Earth, meaning that its structure formed just 2 billion years after the start of the universe. Astronomers believe Newfound Blob is a galaxy protocluster, a giant blob of gas that would eventually go on to produce clusters of entire galaxies, thus giving us insight to how matter in the early universe grouped to form superclusters.
Number 6.
The largest supercluster, Horologium Supercluster. Speaking of superclusters, the Horologium-Reticulum Supercluster, usually abbreviated as Horologium Supercluster, is the largest supercluster of galaxies that we currently know of at a length of 550 million light years. Superclusters of galaxies are exactly as they sound. Giant collections of hundreds of thousands of galaxies loosely gravitationally bound to one another within a large field in space. The galaxy we call home is also a part of a supercluster. Our solar system is a tiny part of the Milky Way galaxy, itself in a small group of galaxies relatively near us that we call the local group. And that local group is just a tiny portion of the Virgo supercluster that we belong to, which may itself just be an arm of the proposed Laniakea supercluster. The proposed Laniakea and Horologium superclusters are actually very similar in size, though from what we know right now, Horologium is currently the largest proposed supercluster and lies at a whopping 700 million light years away from Earth. Knowing that galaxies seem to group together due to gravitational ties and the barely understood dark matter, shouldn't that mean that there are areas in the universe that are empty by comparison as well?
Number 5.
The largest void, giant void. The vastness of what we've covered so far is already incredibly difficult to comprehend, and both the size and the time it would take to traverse even relatively small areas such as our own galaxy make many feel minuscule and isolated on our tiny planet. But perhaps we should feel lucky that our galaxy is located on the outskirts of a large supercluster instead of drifting as a lone galaxy in a void, the loneliest areas in the universe. Andromeda is one of our closest neighbors at 2.5 million light years away, but in a void, the distance to other galaxies and clusters can be tens to hundreds of millions of light years away. If our galaxy was alone, adrift in a large void, our skies would be a little darker, and we wouldn't have known other galaxies existed at all until the mid-20th century. 1.5 billion light years from our galaxy lies the aptly named Giant Void. Its size dwarfs the largest supercluster we know of at more than 1 billion light years in diameter. It's so large that there are even a few isolated galaxy clusters within it, none of which are gravitationally bound as they are so distant from one another. If the thought of supervoids fills you with existential dread, I'm afraid you'll be bummed to hear that we aren't exactly located in a galactic metropolis. In fact, new evidence supporting the existence of the KBC void was recently announced and may soon be confirmed as the new largest supervoid that we know of at 2 billion light years in diameter. Our galaxy, as well as much of the Laniakea supercluster, is located within it, putting a substantial obstacle between us and the greater universe. At least we can take comfort in the fact that we're not alone or near the center of the KBC void, a fate a few less fortunate galaxies will share.
Number 4.
The largest quasar group, Huge-Large Quasar Group. No, you didn't mishear that. It really is called the Huge-Large Quasar Group, usually shortened to Huge-LQG. And yes, I agree that it's a terrible name. If you look far enough into the past, you should be able to see multiple black holes gravitationally bound to one another, each with bright active quasars that would lay the foundations for galaxy clusters and filaments to form. At 9 billion light-years away, the 73 quasars that make up the proposed Huge-LQG extend over a distance of 4 billion light-years, a number which may violate the current cosmological principle due to the size and density of the structure. The cosmological principle states that at large enough scales, the universe is isotropic and homogeneous, basically meaning that if you captured large cubes of space at different points in the universe, they should contain about the same amount of matter. Since the size of the cubes are currently calculated to be anywhere from 300 million to 1.5 billion light-years, a few large quasar groups, galaxy walls and filaments, and the possible supervoid related to the CMB cold spot lie outside of the cosmological principle, though the principle and these findings are still widely debated among astronomers.
I think we found that it's just jive.
No way, unless it's your degree and all that's just jive.
How could this happen to me?
Number 3.
Here we are at the largest singular probable structure that we currently know of. The Hercules Corona-Borealis Great Wall is a titanic-sounding name fitting of a structure possibly extending 6 to 10 billion light-years across. Though the name is a misnomer, as it isn't confined to just the Hercules and Corona-Borealis constellations. The Great Gamma Ray Burst Wall, or Great GRB Wall, is a much more fitting name as it describes the means through which this possible structure was discovered. When hypergiant stars collapse, the north and south poles of the forming black hole shoot out violent beams of energy, which we call gamma ray bursts. Usually, these bursts are randomly distributed at different distances from one another, but many of the 44 bursts at redshift 2 were discovered to be statistically close to one another in a region of the sky including half of the constellations Draco, Lyra, and Boötes, as well as the entirety of Hercules and Corona-Borealis. This led to the hypothesis of an enormous gravitationally bound structure 10 billion light-years away from us encompassing almost an eighth of our sky to explain the anisotropic clustering of the bursts. There is currently a debate over whether the Great GRB Wall is a supercluster or galaxy filament, as its round shape is usually indicative of a supercluster of galaxies. The issue with that is its size being 20 times larger than the largest supercluster currently known. Whatever the case, galaxies within the Great GRB Wall would number in the billions, with trillions upon trillions of stars located within.
Number 2.
The largest structure in the universe, the cosmic web. Our planet is a small part of the larger solar system, which itself is a part of the larger Milky Way galaxy. Our galaxy is a part of the local group of galaxies, which is a part of the much larger Virgo supercluster, and perhaps the even larger Laniakea supercluster. Between these superclusters are vast voids comparatively devoid of matter, forming expansive empty spaces with filaments of galaxies forming around them where most matter collects. The cosmic web is thought to be a connected network of dark matter filaments that binds nearly all matter together throughout the universe. Sort of like a web that extends in all directions, with superclusters and galaxy filaments making up the strands of the web and the empty spaces being voids. You can imagine it like the inside of a foam, or even a sponge. But personally, my favorite comparison is how similar simulations of the cosmic web look to the neural pathways of a brain. A constantly moving, interconnected structure extending throughout the entirety of the universe, encompassing nearly every one of the very recently estimated 2 trillion galaxies in the observable universe. That is the theorized cosmic web. And if it exists, it is without a doubt the largest structure in the entire universe. It's difficult to feel more insignificant, yet at the same time, a part of something immense when thinking of a structure so inconceivably vast.
Number 1.
And the number 1 largest thing in the universe is...
These nuts. Ha! Got him! Ha!
Okay, I know I practically invited this, but it wasn't a request! Look at this! Why isn't my mom number one?
My mother-in-law should be
Why isn't my
number one.
penis number one?
My
I don't see my
dad.
penis on this Your mother.
It's time to
Please, if you plan on commenting something similar to the structure of this joke, at the very least, make it slightly original. Alright, now that we've gotten our jollies out of the way, let's tackle something truly mind-meltingly incomprehensible. The largest thing in the universe is space. No, wait, it's not a joke this time. The furthest distance we can peer into space is about 46.5 billion light years in any direction, making what we call the observable universe about 93 billion light years in diameter. That distance acts as our cosmic horizon, the furthest we can currently see out into the stars, though we don't actually know how big the universe really is. Our universe is currently expanding at a rate of around 22 kilometers per second per million light years, a unit we call the Hubble constant, even though it's not actually constant. Space, the very material that makes up our universe, is expanding and remarkably accelerating every second as it does. Space, or more accurately, space-time, can be thought of as a giant fabric with infinite layers on which all matter and particles exist. The fastest something can move upon the fabric is what we refer to as the speed of light, but the fabric itself can expand faster than that in every direction. It's not that distant galaxies are or will be traveling away from us faster than the speed of light. It's the sum of the space between us that is expanding faster than the speed of light and accelerating as time goes on. This also means that, as time goes on, we will see less of our universe, because the light that allows us to see distant galaxies will no longer reach us. Eventually, the only sight any life in the universe will see besides the light of their own galaxy will be a vast and infinite darkness. However, that eventuality will take several billion years to be realized. So, all the better that we get out there and start exploring as soon as we can. I could honestly spend several more minutes going over this subject, but this video is already the longest we have ever made, and I've simply run out of synonyms for big. If you'd like more info on this subject, check out any or all of these videos. They're great. You know, some people, hearing the news about a colossally sized universe that expands more quickly every day, would have an existential crisis. Yet others instead turn to comedy to cope and make a joke about the size of their genitals or relatives in comparison to the size of the universe, albeit usually unoriginal. Humans truly are magnificent creatures. Let's hope we can spread that majesty to distant stars soon enough. As always, be sure to check the description for sources. Till next video, bon voyage!
Who's putting all this in the bin? How many portions are you putting in there? How much is in the bin? Look! Look!